Hello everyone and welcome back. In this lesson we're going to give a quick overview about the store architectural solution for building user interfaces. As we have seen in the previous lesson, whenever we open here the course component by hitting the View Course button, we are fetching the data that gets displayed from the server each time. And by the way, that also happens whenever we hit here our paginator. Each time we are fetching the same data. This is because this component here, the course component, is responsible for fetching its own data using the lessons data source and the courses service, which does HTTP requests to the backend. Let's have a look at the courses service. This is a standard HTTP Angular service that uses the HTTP client to hit our backend service using these /API URLs that we have here. So it's a standard Angular HTTP service. What we want to do is to store this data not here at the level of the component. Instead, we want to fetch this data if we have not done so already from the backend, and we want to store the data somewhere in a centralized service that has a different lifecycle than the course component. In the current implementation that we have here, the lessons data is linked to the course component. Whenever the course component gets destroyed, that data also gets destroyed. That's why when we have to create the component again, we need to fetch the data a second time. Instead, we want to store our application data in a centralized service that we can have this component subscribed to. Any component in the application, including here the course list component or the view course component that we have here, will then subscribe to this centralized service and receive always the latest version of the data. This means that this component here will no longer be responsible for fetching the data itself. Instead, this component can be implemented as a pure representation of state. This component will essentially behave like a pure function that takes data from the store and projects it into HTML. It will no longer be responsible for fetching and storing the data itself. When the data needs to be modified, this component will not access the data directly. The data is owned and protected by the store. Actually, our store in development mode is going to even be emitting immutable objects, so if we try to modify them, we are going to get an error immediately. In order to modify the data, this component is going to report an event back to the store, which is known as an action. And notice that here we said that the action is an event as opposed to a command. So a good example of an action is course changed. That's an example of something that has happened in the scope of a given component that the component is reporting back to the store via an event. A bad example of an action is increment counter. That's not an event, that's a command. The component is telling to the store how to modify its data. And that's not how we want to use actions in the store architecture. We want to report events using actions, and then it's the store that is going to decide what to do in response to the event. Once the store handles the action that it has just received, it's then going to modify the state that it contains. The store is then going to broadcast the new version of the data to any interested components that are subscribed to it, and the components will update themselves and reflect the new data on the screen immediately. So going back to the example that we gave on the previous lesson, whenever we are editing here a course, whenever we hit save, we are going to be dispatching an action to the store. The store is then going to, as a side effect, reflect the changes that we made here in the data back to the database, but it's also going to update the store data that we have here in memory on the client side. The store works also like a small in-memory database that we are running in the user's browser. That change in the application data is then going to be broadcasted to any interested components, such as, for example, the home component, where this screen containing the list of cards is getting displayed. The home component is then going to show the new data immediately to the user without having to contact the backend or show any loading indicator to the user. The user interface immediately reflects the new data inside the store. The store is going to then become, from the point of view of our client application, the single source of truth in terms of data. The database will no longer be our single source of truth. We don't have to contact it each time. Instead, we simply subscribe to the store and are guaranteed to always receive the latest data. Let's now summarize these very important points about the store architecture. Without these notions, you will have a hard time implementing it in your application. So first, the data is not tied to any particular component. The components no longer fetch the data directly. Instead, the data belongs inside a centralized service which is independent of any component, which is the store. The components, if they want some data, they are going to subscribe to that store service, which is unobservable, by the way. Now, whenever the components need to modify the data, they don't modify it directly. The data is immutable. Only the store can modify the data. In order to have the data modified, the components need to report an event back to the store under the form of an action. That's an event and not a command. So it's the store that is going to decide how to react to that event, either by calling the backend, maybe via an effect service that we will cover, or via a reducer function the store might choose to modify the data directly in memory. The store is then going to emit a new version of the data to any of the interested components. So please keep these very important points in mind as we dive now into the NGRX ecosystem. We are going to add NGRX Store to our application.